Hi folks, this is an introduction video where I will show you how to download a digital elevation model from the Google Earth engine. This video is part of lab number 5 from Spatial Data Science 110. Let's go! So within the script you will see something like this where you are asked to download a digital elevation model. You're hopefully registered to the Earth engine already. If not, you should do so in the first place. And then you're able to open this link. I don't want to click on the link directly because I want it to open in a new tab. And this is what it looks like. So we will see Google Earth Engine menu. If you haven't worked with the Earth engine, we basically see 4 different panels in here. This is the panel where you see all your scripts. So this will look slightly different for you because you will have a different repository structure. You will see some help on the different commands, which you probably don't need. Neither you will need your assets. So we will just stick with the scripts. The other panel which is relevant to you is where the code is typed. So here you have to make certain adjustments. We will walk you through step by step. What you see here in the first place is a bit of commented text which introduces you. So that's basically the documentation of the script. So feel free to read it in the first place. And within that video I will take you through that documentation step by step. Otherwise we see console where certain print commands from our script are printed out. You will find the inspector, which we will also use to get information on certain pixel values. So if you click into a certain location, you will get the information needed, and a task panel which we will need for the export. Most important, what we will focus on now is the map panel at the bottom. Alrighty, so the task is to download a digital elevation model from a floodplain. Where on Earth can we find floodplains? You will get some assistance if we look into the layers menu. You see already the DEM highlighted here. We can use the slider to switch between the typical Earth engine map, and this reminds you that it's helpful to first of all orientate yourself, irrespective of the floodplains. Let's have a look where on Earth we are. We are somewhere in Alaska, close to the Yukon River, and you can use the scroll mouse to zoom in and out. You can do so as well with the respective plus and minus signs. So this is one way to navigate yourself around the globe. Different layers can be highlighted either by using the slider or the DEM, or the checkbox, in this case checkbox for the DEM. And what I would like to point out is that you already have maps which show you where you can find floodplains. The map at the bottom is probably quality-wise the best map. All these areas indicated in blue are areas which should hold floodplains. So these are areas worthwhile testing. On top of that, you have another layer that indicates the global river network. Here it makes sense to zoom into the map again to see where these rivers are in detail. And our first global floodplains map is limited to 60 degrees north and south. So if you're particularly interested in the Arctic, where we've been in the first place, you can initiate the observe floodplains. And you notice already quite a stark difference between these 2 data sets on floodplains. The one above probably doesn't hold all the locations where you can actually find floodplains. So previously we've been in Alaska, and yes, these locations make sense. You probably also find other locations. So there's just to say some kind of uncertainty attached to each of these products. So the data set we will work with most is the DEM. And there's not only one DEM, you can select between different DEMs, but we will come to that point in a minute. More important is that you are that you are able to adjust your area of interest. So in our case, we start out with a really tiny area of interest because we tied it to a high resolution digital elevation model. So if you are, let's move to another place where we might look for flat planes. So we can first select the hand symbol and then select our rectangle, which is the red rectangle which defines our area of interest. This area of interest also pops up here at the import section, so at the very top of our script, so you can see what kind of coordinates are within our area of interest, but you don't have to worry about that. All you need to know is how you can adjust this rectangle, and for that reason you should use the hand symbol to move it around, and you can also use one of the vertices to resize your area of interest. This comes particularly handy if you want to move it from one location to another. So you see it's rather tiny, so if we zoom out, we want to have it bigger, that we can actually select it and move it around. So for example, if we move to another place, Europe, quite built up, I would recommend areas which maybe aren't that built up. Let's have a look at our global floodplains layer. So this area in China probably is quite promising. So now I have to resize the rectangle again, make it a bit smaller as we zoom in. And let's first of all see, yeah, this looks like a big river which is meandering a lot, so this looks like a promising floodplain. Let's resize our area of interest to an area we might be interested in. So let's say, just for the purpose of this video, we don't want to select the urban area, but rather our floodplain, and maybe we look for a section of the river which is east-west oriented. Looks kind of easy then also on the DEM. And our floodplain layer is a bit coarsely resolved, so we would like to know how does our DEM look like. And I selected our DEM, but it doesn't show up. Oops. Why is that? That simply has to do with the fact that the selected DEM doesn't cover this part of the world. So you see already in the description, I think it was further up here, that you can select between different digital elevation models, DEMs. So previously I was using the Arctic 2-meter DEM. However, this only covers the Arctic. So if you want to make sure that you have a DEM that covers your area of interest, choose a global DEM like the Copernicus DEM. It has a lower spatial resolution. Instead of 2 meters, we now go down to 30 meters. But for large rivers, this can make total sense. So should be fine. So I again selected a DEM by just copying the text. So you can go to the Copernicus Global Digital Elevation Model and insert it in here. So it comes with a 30-meter spatial resolution. For that reason, we should also adjust the scale variable to 30 meter. That again makes sense also for our export. And if you change anything within your script, you can press run to run our script accordingly. And we see that within our console, all these print commands also get adjusted depending on what we changed in our script. So we changed the scale parameter. For that reason, we don't work with 2 meters anymore rather than with 30 meters. We should, of course, also change the respective file name. So here probably is a good idea to insert which kind of DEM you used and adjust the spatial resolution. We also changed the location of our river. This is the Changhua River, so not the Birch River anymore. Changhua. And the rest should be fine. We can leave it as it is. And now if we press run again, the name is also adjusted. All good. So if we focus now on the map section, we see it's quite green. For our area of interest, it's a bit too green for my taste. I don't really see the values within the DEM. This is because we have to adjust the minimum and maximum value of our color ramp. This was still the case for the previous example. Now, the question is, how can you possibly know what is the correct minimum and maximum value? Good question. You can answer that by just using the inspector. So we want to know what is an approximate minimum value. I suspect that river is flowing from the west to the east. So I click into, I want to know the lowest location, so that will then be in the east. And within the inspector, we will see for each layer the respective value for the pixel we just clicked into. So here we end up with approximately 118 meters. Yes, confirmed. So this will be our minimum value. And now we also need a maximum value. Now I don't want to look into the river section. We probably have to make consecutive attempts to also get the high elevations. So here we are outside the river at the westernmost end, somewhere around 130. So now we redefined the minimum and maximum value. Let's have a look how this looks within our DEM. And actually, looks quite good, doesn't it? We see the different lobes of the river, so it's very much meandering. Everything highlighted here in yellow is supposed to be the floodplain. And here, these white areas, what are these supposed to be? These are areas with a location higher than our maximum value, with an elevation higher than our maximum value. So here, 170 meters, way above 130. We will change that now to 180. Probably some of these areas will also be included within our DEM. However, I would like to go back to our 130 and make sure that we focus on the floodplain, which is the area we are really interested in. So now that you know how our floodplain looks like, you may want to resize our area of interest. So for that reason, you can use the hand tool again and resize it. By the way, if you accidentally, delete our area of interest, can happen, you can easily redraw it. Just use the rectangle tool, draw a second rectangle. If you accidentally redraw your area of interest, and like me, you end up with now 2 rectangles, which you don't want to have, because otherwise your area of interest will just increase, you can easily select it again with the hand tool and use backspace to delete it. Play around with these tools. You can't possibly delete anything. That script you can change for yourself, but whenever you go back to the original link, you will get back to the original state of that script. You can save that script if you made any adjustments using Save As, and then you will be asked to save it within your own repository. And this is a way you make sure that you can reproduce whatever you've done. So let's say for now we are happy with our definitions we have to provide in the first place. So my computer is slow. This took me quite a while, or sometimes can take quite a while, until that Save As option actually triggers. However, let's make sure that we have all the changes in place which should be in place. So we redefined our DEM, and again, feel free to choose between all the different DEMs you have available here. We made sure that we redefined the scale parameter. Why is the scale parameter relevant? Simply because it gives you an estimate of the file size. In our case, it's actually rather small. So these 30 meters spatial resolution means that each pixel has a width and length of 30 meters, which is not a great spatial resolution. So for that reason, we end up with a rather small file size, which is not a problem, but also is just an indicator that we can easily go with a larger file size. I would recommend that you have file sizes maybe around 5 megabyte. You can go up to 50. Beyond that, you probably run into issues within QGIS. So I would recommend move around, 5 to 50 megabyte within your DEM. If you would have a higher resolution DEM, let's say 2 meter DEM, your file size will quickly increase, right? So here we are already above the recommended 50 meter max ceiling. So if you're still interested in a large area, you can also change the scaling of your DEM. So this parameter not only changes the estimated file size, it will also influence at which scale your DEM is exported. So let's say you're working with the Arctic DEM at a 2 meter spatial resolution, but you don't want to have it at 2 meter, but rather at 10 meter. Right, just type in 10 here and it will be exported at a 10 meter spatial resolution. So finally, just make sure that you have all these parameters set correctly. So in our case, we would have to go with, well, you can interpolate your DEM and go from 30 meter to 10 meter, but that doesn't give you actually more information than would be incorporated in that 30 meter DEM. And the rest is fine. The rest is fine here. What you need to know, once you're happy with all the definitions you provided, press run for a final time, just to make sure everything is taken up. And you can now go to the task panel and export your DEM by just pressing run. This will again show you a window which summarizes all the relevant parameters. You don't have to worry about the coordinated reference system. This one is taken up automatically for you. And what you will see, pay attention to the scale, the name. It will be a geotiff and exported to an EE export folder, which you will find in your Google Drive. So this is a Google Drive export. Once you have Earth Engine account, I suppose you should have access to, now it goes via a Google account, so you need to have a Google account to work with Google Drive. If you don't have a Google account, don't worry, just ask a colleague of yours and we will find a solution. Otherwise, ask me. You can also easily send me your script. If you press on Get Link, you can copy the link to your script. So there are various options to make sure that you will be able to export your DEM. And you find it in Google Drive, and there you can download it and incorporate it, import it into QGIS. Okay, What else is relevant? I think we covered most of these parameters. Feel free to have a look into the script. Try to understand it if you like. If you have questions, I'm happy to answer them. Again, you can manipulate the script. You won't destroy the script itself, just your version of the script. Everyone else will have access to the original script. So for that reason, be playful. Otherwise, have a great day and get out of here.